second step of the salt analysis, that is the identification of acid radicals or anions. Now these anions, which you can see all over here, they are divided into three groups: group 1, group 2, and group 3. And every group has got a group reagent. This period table which you see is totally different from the periodic table. So don't get confused. This is based on their solubilities and reactions they have been classified as. So group 1, the group reagent is dilute HCl, and it contains carbonate, sulfite, nitrite, sulfide, thiosulfate. And group 2 is chloride, bromide, iodide, and nitrite. Group 3 is sulfate and phosphate. There is no group reagent for group 3, but for group 2, it's concentrated sulfuric acid, and for group 1, it's dilute HCl.
So we have this group 1 salts. The first one is carbonate, second one is sulfite, third one is NO2. We are not doing sulfide S2 because it's producing H2S, but is having very bad smell. And the fourth one is S2O3, thiosulfate. So now the group reagent for this group is HCl. We are adding HCl in every one. And carbonates, when we are adding HCl, so you see that the gas is produced. This gas is colorless and this is carbon dioxide. So this is the identification of group carbonates, that if you add HCl, carbonates react with HCl producing carbon dioxide. And the second one, where we are having sulfite, when we add HCl, the gas is produced, but gas is colorless and it is having bad smell. Sulfur dioxide gas is produced in this case. And third one, nitrite. When we add HCl, the group reagent, so you can see that the brown color of gas is produced, and O2. This gives you the idea that the given salt is nitrite. It will be containing NO2 like potassium nitrite, calcium nitrite, sodium nitrite, etc. And then fourth one, we are adding HCl. It is also producing the gas sulfur dioxides like SO3. But the difference is that there it is totally colorless. Here in thiosulfate case, you are getting this yellow PPT at the end. So this is further identification. One, SO2 gas is produced. Second, this yellowish PPT is formed in the solution. So you can see that it is becoming milky. It was clear solution before, but now after passing carbon dioxide through lime water, it is becoming milky, like milk color, halib. This is the salt of nitrite, potassium nitrite. The radical is NO2, and the conformity test is that if we add acidified potassium iodide and then add starch solution, due to starch it is becoming dark blue colors you are getting, right? So this will be the conformity test. So it is confirmed that the given salt was having nitrite anions. Now we will have to see the conformity test for thiosulfate. already the solution is there for thiosulfate, and one of the conformity tests for thiosulfate is that if we add iodine solution, the iodine solution will decolorize. You can see this brown solution. If I add 1 or 2 drops, so you see that still it is clear solution, the color is removed from the iodine. So this is test for thiosulfate.